Alright guys, today's video is to give you guys a basic understanding of Kirchoff's voltage and current laws. So as we know from last video, voltage can be defined as the difference in electric potential at 2 points. So let's take a look at these 2 points here. So with Ohm's law, we can solve for current and we end up getting 1 amp. So now we have a resistance and a current. So we can calculate the voltage at this point. And we end up finding that this voltage here is 5 volts. And since our source voltage is 5 volts, that means that it's dropping 5 volts right here. And this is the potential difference between these 2 points here. Now let's look over at this circuit. We have a 10 volt battery connected to 2 5 ohm resistors in series. So again, we can calculate our current, and we end up finding that we have 1 amp of current. And if we look at the voltage drop at this first resistor here, we see that we get a 5 volt voltage drop. And we look at the second one, we also get a 5 volt voltage drop. So we can kind of see a very small pattern here with the little amount of data that we have. It seems like the voltage of the resistors is equal to the voltage of this battery here. And this is pretty much Kirchoff's voltage law. So this says, in any closed loop, the sum of all voltages equals 0. So in this first one here, we have the 5 volt minus 5 volt, and we got 0 volt. In the second one here, we have 10 volt minus 10 volt, and we have 0 volt. So we can also get a little equation here to find the voltage drop at a particular spot. So let's say we want to find it for the 5 ohm resistor, the voltage drop. And these are all in series. We have a 5, a 10, and a 15. If we take our 5 ohm divided by the total resistance of this, we can get a proportion that when multiplied to our voltage source will give us the voltage between these 2 spots here, or the voltage drop of here to here. Next, we're going to look at the voltage drop of our 50 ohm resistor in this circuit here. So we're going to do the same as we did before. We have our 50 ohm resistor here, and we're going to divide this by the total resistance of this circuit. And we see that we have a 10, a 50, and a 20. And then if we multiply this times our source voltage, we're going to find the voltage drop of this 50 ohm resistor here to here. And we find that it's 6.25 volts. Now let's talk about Kirchoff's current law. And it pretty much says that the current in a node must equal the current out. So here we have a node, and we have 3 currents going in and 1 going out. So this 1 current going out must be equal to the sum of all of these added up. So we can use our analogy of current to visualize this a little better. If we have a stream that forks off and goes into one spot, we're going to see that the water of these 2 forks is equal to the water of the main part of the stream here. And we can use this idea to solve basic little nodes like this. So we have 5 amps going in, 2 amps leaving, 4 amps leaving, and 3 amps leaving. And we want to find the current measured in this direction here, left to right. We see that our current in is 5, and our current out is 2 amp plus 3 amp plus 4 amp plus this I value. So now if we set them equal to each other, since they must be equal to each other, we'll find that 9 amps plus I equals 5, and that this current measured left to right is a negative 4 amps, which is pretty much saying that it's actually moving right to left at 4 amps. Alright guys, I just want to talk a little more detail about what a node is. So a node is defined as where the terminals of 2 or more circuit elements meet. So I have a circuit drawn here with a couple components, and we have 3 elements here, so we have 1 node drawn in blue. We have 3 elements here, and we have this node drawn in orange. And then we're going to have 1 node on the bottom here, which is where all 4 of these components meet. And is this going to be a node? Well, if we look at the definition, 2 or more circuit elements, yes, it would be a node. Just this little guy right here would be considered a node. So next we're going to talk about applying Kirchoffs voltage law that we learned earlier, which is the voltage in a closed loop must equal 0. So if we look at this here, we know that this loop here is going to have current. And since we use conventional current, we're saying that it goes clockwise. And whichever way the current is going into with this sign here, we're going to make that negative. So we have the current moving from left to right here. So this is going to be a positive. Top to bottom, this is going to be positive. Right to left, this is going to be positive. And bottom to top, which is going to be negative. So, and we also know that voltage equals current times resistance. So if we take our current times our resistance, this should give us a voltage. So we can set up a little equation here where we say that our negative voltage source, which is our 5 volts, and remember it's negative because this is the direction that we're measuring our current, plus I times 10 ohm plus I times 5 ohm plus I times 3 ohm is equal to 0. And then if we combine all of our like terms here, we'll see that our voltage source is equal to I18. So our voltage source divided by 18 ohms is equal to 0.28 amps. So now what's going to happen if we have a more complex circuit like this one drawn here? We're going to want to break it up into 2 different loops, an I1 and an I2. And we're going to do the same thing as earlier. So with our sign convention, again, we're going to see that this is a negative, positive, positive. And then whenever we're using this one, we're going to see that this is negative, positive, positive. All right. So now if we do this, we're going to see the Kirchoffs voltage law on I1. We see that negative 5 volts plus I1 times 7 plus 2 I1 minus I2 is equal to 0. And all this is we can figure out the current in this direction by subtracting it from the current going the other direction. So if we just look at our little diagram I have drawn right here, we see the current going down here, and then we see the current going up here. So if we want to find it in the downward direction, we're going to do the I1 minus I2. So now let's take a look at KVL on I2. 2 ohm resistor multiplied times I2 minus I1. Since we're trying to find it in this direction, so it's going to be the current upwards minus the current downwards. And if you want to kind of visualize this better, it's always the direction that you want minus the opposite direction. So now we see that 9I1 minus I2 is equal to 5, and negative 2I1 plus 11I2 is equal to 0. And this ends up giving us an I1 of 0.58 amps and an I2 of 0.105 amps. So that means the current over here is 0.58 amps, and the current in this loop right here is 0.105 amps. And if we wanted to find the current right here going downward, we'd use this I1 minus I2. All right, and to solve this, I just used substitution or elimination, and I'll give you guys a quick refresher on that. All right, so here's our equations from earlier that we found. 9I1 minus 2I2 is equal to 5. Negative 2I1 plus 11I2 is equal to 0. So I wanted to solve for I2 first. So I kept I2 on one side and brought I1 over for the second equation. And this one I thought would be easier since it didn't have this constant over here on this side that we had to worry about. So then we end up finding that I2 is equal to 2 over 11 I1. Now all we're going to do is substitute this 2 over 11 I1 in for wherever we see I2 in our equation. And I put it back into this top equation here, which you have to use the opposite equation you used. And I ended up getting 9I1 minus 2 parentheses 2 over 11 I1 end parentheses equal 5. Now I distributed this in, and I got 9I1 minus 4/11 I1 is equal to 5. which if we combine them by getting a common denominator, we end up getting 99 over 11 I1 minus 4 over 11 I1 to give us 95 over 11 I1 is equal to 5. Now all we have to do is solve for I1. So we're going to move over this 95 over 11. We're going to divide it over, and dividing is the same as multiplying by the reciprocal. So we can say that 5 times 11/95 is equal to I1, which gives us 55/95 and a current of 11 over 19 amps. Next, we're going to take this 11 over 19, which we solved for I1, and just plug it back in for I1 to find I2. So we end up getting this equation here, which when this -2 is distributed in, we get -22/19 plus 11 I2 is equal to 0. Now if we divide through this 11 here, we end up getting that I2 is equal to 0.105 amps.